Look in a mirror and you know there is an eye looking back. You have an identity, a continuous thread of subjective experience. Yet, if you look inside your skull, you find 3 pounds of wet tissue, a network of carbon, water, and electrical impulses. The standard scientific reflex when faced with a complex system is to zoom in. This is the heart of reductionism, the idea that a whole is best understood by breaking it down into its smallest biological parts. But if you isolate a single neuron under a microscope, you won't find a memory of your childhood. You won't find your sense of humor or your personality. The closer you look at the physical building blocks of the brain, the further you get from anything resembling a human mind. This creates a central tension. If your identity isn't physically located in the matter of your brain, is consciousness an illusion? Or is the self something that exists independently of the matter it's built on? In 1979, cognitive scientist Douglas Hofstadter published a massive treatise exploring how a conscious mind can rise out of completely unconscious material. To explain it, he imagined an ant colony. He asked readers to look at the colony not as a collection of bugs, but as a single conscious entity whose brain cells are individual ants. At the lowest level, a single ant wanders randomly. It has no map, no intelligence, and no concept of the overarching system. It reacts blindly to the environment immediately in front of it. But when a critical mass of ants gather, those random motions stop being random. The ants bump into each other, exchange chemical cues, and form organized teams. They build complex trails and adapt to shifting environments, effectively sending information across the colony. This model illustrates how a conscious entity can emerge from building blocks that have no consciousness of their own. The individual ants remain clueless, yet the colony as a whole behaves with purpose and intelligence. Just as a single worker ant has no idea it is helping the colony locate food, a single neuron in your brain has no idea it is helping you think. Hofstadter argued that when enough of these mindless biological parts interact, they cross a specific threshold of complexity. The network begins to map and track its own internal states, creating what he called a strange loop, a pattern of information that folds back on itself until it perceives its own existence. This architecture treats the biological brain as the hardware that supports the software of consciousness. In this framework, you need the physical machinery to run the code, but the hardware itself is not the source of your identity. Instead, the self is the abstract pattern. This theory faced a brutal test in 1993, when Hofstadter's wife, Carol, died suddenly. In an instant, the physical hardware that hosted her mind was destroyed. Yet, as he navigated the grief, Hofstadter realized that her specific ways of thinking, her humor, her quirks, and her emotional reactions were still generating responses in his own mind. Over years of marriage and constant interaction, her brain and his brain had influenced one another. The specific informational pattern that made up her identity had effectively copied sections of its code into his neural networks and into the brains of their children. Hofstadter viewed this as a preservation of her identity, a lower resolution version of her mental pattern that continued to function within the hardware of his own mind. It suggests that humans are not closed systems trapped inside our individual skulls. The reality of human connection is that our minds constantly bleed into the minds of everyone we care about. This human self is an information pattern that outlives the physical body, persisting through the minds and memories of those who loved it.